Hello everybody, welcome to this guided activity of your physics foundation class. In this activity we want to learn about waves and interference, and we want to learn about superposition and how to create a beat pattern with the software online. So to accomplish this task, I would like you to go to google.com, and in google.com in the browser window I would like you to type desmos.com. So that is desmos.com. So this is a free website where you can use the visualization tools to understand how mathematical functions look like. So let's click on this graphing calculator option, and you don't need any login to do this. It will take you to this page in which on this left hand side you will see a place where you can type in your equation. So let's type in our equation for our simple harmonic wave, which is a cos kx minus omega t, and as you can see it doesn't recognize the capital C, so you will have to reduce the to lowercase, and you will have to define what all the values of a, k, omega and t is. So let's just click on each of them, and so you will see these sliders, they appear in the bottom, and it just gives it a numerical value of 1 to begin with, which you can change. So you can see the graph appears on the right hand side, and it looks like a sinusoidal curve. So you can play around with these values and change the value for time, your k value, omega, your frequency can be changed, and you can change your amplitude as well. So all these values you can change and play around with it and see how the graph changes. So if you increase the amplitude, it's visible on the graph. You can change the value for k. You can play around with the time. So I would like you to pause the video here and explore these options. Additionally, what you can do is copy the equation, and you can just paste it down here, and by doing this we can start to do our visualization for our interference patterns. So what I have done here is I have changed the values of y to y1, and I have indexed my k1, omega 1 and t values. The reason the graph appears red is because we have chosen the color from the left hand side. As you can see, you can make a graph visible and you can make a graph disappear if you want. And we have added another equation in the bottom, and in this equation you can see I have used different values for my amplitude. I have labeled them b, k2, omega 2, and I have kept the color as blue, so you can choose these options. And what I have down here is a resultant function, which is the sum of these two simple harmonic equation. And now if I make the r resultant value visible, which is black, then you will be able to see that there is a constructive interference that happens because both of these red and the blue curves are in phase with each other. So let's go ahead and change the phase a little bit. Let's create a phase change of pi between these two functions, and if you do that, immediately you will see that now we have the blue and the red functions. One has a positive value, one has a negative value, and by doing that you get a resultant function as 0. So I would let you pause here for a while and play around with these functions so that you can understand how the phase change causes different patterns, as you can see here on the graph. Okay. In this next exercise, what we want to do is we want to change the values of k and omega to create a slightly difference in the frequency, and let's look at just the resultant waveform so that we have a clear picture of how to get the beat pattern. And at this point what you can do is you can change all these k values. Basically when you're changing this k2 value, you are changing the difference between one k value of y2 from the other. You have the option to change omega as well, so you can go ahead and change omega as well. So as you change this, for example, value to 2.1, the omega 1 value was 1, so the difference is 1.1 between them. Okay, so to create a beat pattern, you will have to find a slight difference in the frequencies for that beat pattern to be visible. Okay, so again I would like you to pause here and try out different values of omega and k, and let's see if you can create this pattern that looks like a beat pattern due to interference of two waves of slightly different frequencies. And you can change the value of amplitudes so that the graph is much more clearly visible to you when you're creating the beat pattern. So you can see if you hit the right difference between the values, you can create a very good looking beat pattern from the settings of your omega and k right there. Okay. Additionally, with this Desmos website, you have the option to save your work as well. So there is a login option on the right hand side. You can use your Google account, and from your Google account it will ask you to log in, and you can just choose your user ID and password to log in. There is an option on the top left hand corner that you can choose the title of the graph. Let me call this constructive and destructive interference. And let's hit save, and so now this graph will be saved on your profile. So I have a lot of graphs I have already saved from other visualizations. So let me take you to a traveling wave visualization in which one of the waves is moving and the other one is stationary. So the reason why you can see these waves are moving is because as you can see, this time slider we have kept it in the running mode. So there is an option here on the left hand side to hit play, and you can choose the bounded limits here from 0 to whatever time, and if you just click play, then basically a time will run between these two bounded values, and that creates this moving green curve, and when it interacts with this purple curve, it is creating this oscillations of your resultant wave. So you get this traveling wave oscillations. Okay, so again you can choose these graphs of different color so that you can differentiate one from the other, and there are many other options in Desmos that I would like you to explore, and I hope you find it as a very useful tool for visualization of mathematical functions. Thank you.